Hello students, and welcome back to another geometry video. You know what to do by now. Pause the video, try these questions in your notes, and then unpause them, and we will talk. So, do you remember what parallel lines are? Do you remember what perpendicular lines are? So, hopefully you tried to give a definition of both of them, use words and pictures. And then, what do you think skew lines are? That's how we say this word. We say it skew. What do you think skew lines are? Think of section 1.1. So, you have probably heard about parallel and perpendicular lines before. We talk about them in algebra. Parallel lines, and we'll talk more about this later, never intersect. They have the same slope. And perpendicular lines meet at a 90-degree angle, and they have the slope of a perpendicular line is the negative reciprocal of the other line. So these are the pictures and then the words we just said out loud. Skew lines, though, this has to do with 1.1, and we are going to talk about those in this lesson. So let's jump right into it. Welcome to Chapter 3. This is section 3.1. We're going to be talking about pairs of lines and angles. So pairs of lines, angles formed by pairs of lines, and so on and so forth. Our learning target: by the end of this lesson, you should know what parallel, perpendicular, and skew lines are, and you should know about special angles created by transversals. Now, you probably have never heard the word skew or transversal before. That's okay. We're going to learn about both of those things in this lesson. We'll also learn about parallel and perpendicular, but you've probably already heard about those before. All right, and our success criteria: what should you be able to do at the end of this lesson? Well, you should be able to use diagrams to identify special angles and parallel, perpendicular, and skew lines. So you should be able to identify, that's the key word. You should be able to identify each of the things that we mentioned in our learning target. So without further ado, let's jump into some vocab. These are probably review. Parallel lines, two lines in the same plane. Now this is where the entry task told you to remember section 1.1. That's because parallel lines must be in the same plane. So, parallel lines need to lie in the same plane. If one, so it's stronger than just never intersecting. Because I can have two lines, so right here, they're in the same plane, you can see. But what about this? They never intersect, but they're not parallel because they're not in the same plane. Okay, and perpendicular lines intersect to form a right angle. They don't need to be in the same plane, although they create a plane together, but they need to intersect to form a right angle. That is the basis of the definition. So this red box right here, that's what tells you that two lines are perpendicular, and that's what tells you that you have a right angle. So that box will be important to us. And this symbol right down here, it's like an upside down T. Let me draw this bigger for you. They have L, upside down T, M. And what this means is perpendicular to. So line L is perpendicular to line M. That's what that means. Okay, so that was a nice review of parallel and perpendicular lines. Now something new! Something new to Chapter 3, skew lines. These are lines that do not intersect and are not coplanar. So parallel lines, if my arms are lines right here, parallel lines need to be in the exact same plane and never intersect. Skew lines, they never intersect. See my arms? They never intersect. but they're not parallel because they don't go in the same direction. Skew lines could be pointed in different directions, but they still never intersect. So something like line P and line N here. And the way that you know they don't intersect is, see how P is a dotted line right here? That means that the line P is kind of behind the plane. It's like if you stabbed a pencil through a piece of paper. This line is going through the plane, but line N is still sitting in the plane. So, P and N, this is P, this is N, they don't intersect. They don't intersect, but they are not in the same plane. So that's what skew lines are. Parallel, perpendicular, and skew. Okay, now, this is a nice review of everything that we've just talked about. So lines that do not intersect are either parallel lines or skew lines. The difference is that parallel lines do not intersect and are coplanar. Skew lines do not intersect and are not coplanar. Two planes that do not intersect are called parallel planes. So you'll see right here, plane T and plane U are parallel planes. Lines M and N are parallel lines, and I'm going to zoom in on this. When it says lines M and N are parallel lines, notice this symbol right here. What is that? This, so I'm going to write this bigger. We have M, two vertical lines, whoops, two vertical lines, and then N. What this symbol means is parallel to. Just like we talked about earlier, that upside down T means is perpendicular to, this means is parallel to. And how do you know, from this diagram, how do you know that lines M and N are parallel? You see these red lines right here? Or, excuse me, not lines, these red arrows? That's what tells you that two lines are parallel. When you see the red arrows, it means yes, these lines are parallel. Lines M and K are skew lines. And look at that, that's because M and K don't intersect. M is over here, and K goes straight up and down. Planes T and U are parallel planes because they never intersect. It's like if I had a piece of paper right on top of another piece of paper, those pieces of paper don't intersect. They're just above one another. And then lines K and N are intersecting lines, and there is a plane containing them. It's not shown, but if ever I have two intersecting lines, they create a plane. I can go in this direction, and I can go in this direction. So together, that makes up my whole plane. And you'll learn more about that in linear algebra. Oh boy, will you. Okay. So yes, small directed arrows, we talked about these, and we talked about this. Beautiful. Let's move on to our first example. Zoom out so we can see the whole thing, shall we? Think of each segment in the figure as part of a line. So even though BG might be a segment, they want us to think about it like a line. So even though it doesn't have the arrows saying it goes on forever and ever, we're going to act like they're lines, even though they're drawn as segments. Which lines or planes appear to fit the description? Part A, let's do this in colors, shall we? Part A, we want lines parallel to CD containing point A. So my answer has to have point A in it. It must contain point A. Okay, here's point A. And I want a line or lines that are parallel to CD. Well, here's CD. To be parallel means that I need to be in the same plane So the plane made up by these 3 points is this plane. It's the top of the box, which means that in order to stay in that same plane, this will be my parallel line. Line AB. And don't forget your arrows. If you don't put arrows, it's not a line, it's a segment, and they asked for a line. So we needed to contain point A, and we did that, and we needed to be parallel to CD, and we did that as well. So there's our answer. Okay, new color for part B. Lines skew to CD and containing point A. Okay, so we're still containing point A. And now we want to be skew to CD. That means we do not want to be in the same plane. So, let's see, we could do line AG. That's not in the same plane, and it won't intersect CD. So I could have line AG, but I could also have line AH. This line is also not in the same plane, and it won't intersect line CD. So we could also have line AH. Okay, and remember, we needed to contain point A. So there might be other lines that are skew to CD, but they would not contain point A, and we need it to contain point A. All right, part C. Lines perpendicular to CD and containing point A. Okay. Perpendicular to CD, containing point A. Perpendicular means that I meet at a right angle. In order to know if I meet at a right angle, I need to see one of these red boxes. So, here is a red box in the corner between CD and AD. So, AD is a line that is perpendicular to CD and contains point A. Be sure that if on your homework on a test, if it says containing point A, do not name any lines other than the ones that contain point A. Okay. Wonderful. That's part C. There are no other lines. In fact, there is only one line. Through any point, there is exactly one line that is perpendicular to another line. So, we should only have one line. And let's move on to part D. Planes parallel to EFG. EFG is this plane. It's like the bottom of the box. And we want planes parallel to EFG containing point A. So if I had a box, what plane would be parallel to the floor? Well, you're kind of sitting in a box right now. You're sitting in a room, and the floor is parallel to what? The ceiling, right? So the top of this box contains point A, and the top of the box, if it's a true box, should be parallel to the bottom of the box, just like the ceiling should be parallel to the floor, unless you have like a slanted ceiling or something. But typically, ceilings are flat, just like the floor is flat. So, plane A, B, D. Or ABC, tons of different names for this, right? We could call it CDA, we could call it CAB, we can, we take any one of these points, any three of these points and put them together. Okay, are there any other planes parallel to the bottom of the box that include point A? No, right? All the sides of the box, if you think of like the sides of a room, all of the sides of the box intersect the floor. All the sides of the room intersect the floor at a 90-degree angle. So no, the top of the box is the only one parallel to the bottom of the box. Beautiful. We can check our answers. But only AB contains point A. Both contain point A. Only AD contains point A. ABC and contains point A, because they all need to contain point A. So yay. We were right. Okay. So I alluded to this. I talked a tiny bit about this in the last example, but now let's talk about it more in depth. I mentioned the perpendicular postulate. I didn't name it, but I mentioned it. There is a line, if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So let's break this down. If there is a line, here's our line, and a point not on the line. There you go. There's a point not on this line. Then there is exactly one line through the point. So through this point, there is exactly one line through the point perpendicular to the given line. So if I want the line through this point to be perpendicular to this line, there's only one of them. This line will go through this point and be perpendicular to, let's name it line L and point A. There is only one line through point A that will be perpendicular to L. And it's this line right here. We could call it M. There is no other line. If I tried to make like this line, oh, nope, that's not perpendicular. That's obtuse. That's not a right angle. So any other line you try to make is not going to be perpendicular. Now the parallel postulate says something very similar. If there is a line, we'll do this in a different color. If there is a line and a point not on the line, then there is exactly one line through the point that is parallel to this line. So, and again, we'll call this point B, line N, and we can call this line P. There's only one line, line P, is the only line through B that will be parallel to N. Because any other line I make, well, it's eventually going to intersect with line N. So there is only, through any one point, there's only one line that I can make that will be parallel to line N. Okay, cool. And notice how we have our parallel markings and we have our perpendicular markings. Beautiful. So let's use these problems in an example. Let's identify parallel and perpendicular lines. So, the given line markings show how the roads in town are related to one another. So when they say line markings, they're talking about these arrows, these corner boxes, and things like that. Excuse me, I'm gonna get a different color. So, name a pair of parallel lines. Well, remember, parallel lines are shown by those red arrows. That means that this line and this line are parallel. So, line DM, line DM is parallel to line EF. Beautiful. Okay. Different color. Name a pair of perpendicular lines. Okay. Well, remember this box means perpendicular. So that means that this line, BF, or BM, we could also call it BM, whichever you want. BF is perpendicular to this line. That's getting kind of muddy. Let's erase some of this. So BF is perpendicular to MD. Now for a second I thought A, but no, A is this point. It's not on the line. It's not on this line. Okay, beautiful. Last question. Is FE parallel to line AC? Let me clear up my diagram. Is FE, that's this line right here, and in fact, let me make this thicker. Is FE parallel to AC? Ooh, what do you think? Are those two lines in the same plane that will never intersect? No. No, these are obviously going to intersect. If I continue these lines on, look, they intersect right there. So no. No. Because, so line FE and line AC may be in the same plane. And they are, right? Because we're talking about roads, and roads are on the ground. So they're in the same plane that is the ground. So they may be in the same plane, but they will intersect. So they are not parallel. Because parallel lines never intersect. Okay, and there we have it. Let's check our answers. MD parallel to FE. Yup, just like we thought. MD parallel to BF. Or excuse me, perpendicular to BF. And is not parallel because, ooh, they gave a different reason. We said, oh, they're going to intersect, but also they cited the parallel postulate. MD is parallel to FE, and there's only one line through M that is parallel to FE. So, okay. So either our answer would have worked too, our answer works just as validly, but this is also an example of using the parallel postulate. So, yay. Yay. The important thing was that we said it was not parallel to, and we gave just as valid of an answer. Okay. All right. Let's start the last thing we're going to talk about today. The last thing we're going to talk about are transversals and the special angles created by transversals. So, a transversal is a line that intersects two or more coplanar lines at different points. What that means is that if you have a picture like this, if you have two lines like these, this is a transversal. The line that cuts two or more coplanar lines is called a transversal. And in fact, maybe I'll color code that. So the transversal is this line. The one that cuts two or more coplanar lines. So this line T is the transversal. Okay, so we're going to get into 4 special angle pairs today. Special angles formed by transversals. So if you have not been taking notes, definitely take notes and write this down. This picture with the name corresponding angles. 2 angles are corresponding angles when they have corresponding positions. Now, when we say corresponding, we mean the same. The same position, but in a different place. So notice how if we look at this intersection, 2 is on the top right. And if I look at this intersection, 6 is on the top right. So because 2 and 6 are both in the same position in the top right, it means that they are corresponding angles. So, corresponding angles are in the same position, just in a different place. So, I would say same position, different place. Okay, we're going to talk about 3 more special angle pairs. The second are called alternate interior angles. Now, when you hear the word alternate, what do you think? When I think alternate, I think opposite. So, notice how in this diagram, T is my transversal, 4 is on the right of the transversal, and 5 is on the left of the transversal. So they are on alternate sides. They're on opposite sides of the transversal. So that's where the word alternate comes in. Next, we see the word interior. Interior, because if I look at the two lines being cut by the transversal, 4 and 5 are on the inside of those two lines. They're not on the exterior, they're in between. 4 and 5 are in between these two lines. So they're on alternate sides of the transversal, and they're in between the transversal. So that's why they're called alternate interior angles. So make sure that this picture is in your notes. Two lines cut by a transversal, alternate interior angles. And I'm going to bring back our beautiful annotations as well. Okay, third type of angle. Angles, alternate exterior angles. Okay. Alternate because, check it out, they're on opposite sides of the transversal again. One is on the right and one is on the left. So we're on alternate or opposite sides of the transversal. And exterior because, look at this, they're on the outside of the two lines. They're on the exterior. They're not in between the two lines. They are on the outside. They are exterior angles. So, these are on opposite sides of the transversal, outside the two lines. Okay. Last one. Last set of angles formed by a transversal are called consecutive interior angles. What do you think of when you think consecutive? If I play 2 consecutive baseball games or 2 consecutive soccer games, it means I'm playing one right after the other. I'm playing one soccer game, and when that one ends, I'm playing another soccer game. So notice these angles come one right after the other. We have angle 3 and then angle 5 are right there. They are consecutive. They're right close to each other. Consecutive interior. Look at that. They are on the interior of the two lines. So this is why they're called consecutive interior angles. And let me show you what the picture looks like again without the annotations. Put this in your notes. If it's not in your notes, put it in your notes. There we go. And we'll bring the annotations back. So, these are our 4 types of angle pairs formed by transversals, and they are very important. This is what we're going to be talking about for 3.2 and 3.3. They are all about these 4 pairs of angles. So make sure that you know these. These are huge. We're going to talk about them in 3.2. We're going to talk about them in 3.3. So here is all of them at the same time. Corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. So I'm just gonna I'm gonna put little black marks so that we can see, how is this gonna, so that you can see their positions. Top right, that's corresponding, they're in the same position. Alternate interior, you can see they're in between the 2 lines, but on opposite sides. Alternate exterior, and consecutive interior. Consecutive, one right after the other. Okay, let's do an example, our last example for this video. We want to identify all pairs of angles. All pairs of angles of the given type. So first, let's look at corresponding angles. Now, corresponding means in the same position. So here, angle 1 is on the top left, 5 is on the top left. So, angle 1 and angle 5 are corresponding. Angle 2 is on the top right, and angle 6 is on the top right. So angle 2 and angle 6 are corresponding. Pause the video, see if you can find any more corresponding angles. Unpause it, and I'll do the rest. Angle 3 is on the bottom right, and angle 7 is on the bottom left of this intersection right here, bottom left, and of this intersection right here, bottom left. So angle 3 and angle 7 are also corresponding. And yes, there is another one. Angle 4 is on the bottom right, and angle 8 is on the bottom right. So also, angle 4 and angle 8 are on the bottom right. So they are corresponding. Okay, new color. Alternate interior. Interior means that I need to be in between the 2 lines. So when I say alternate interior, I am only looking at angles in this space. I'm only looking at angles in between the 2 lines. So I could look at angle 2, angle 4, angle 5, and angle 7. But I need to be alternate. I need to be on opposite sides of the transversal. So 2 and 7 are on opposite sides. So we have angle 2 and angle 7. But angle 4 and angle 5 are also on opposite sides of the transversal. So I have angle 4 and angle 5 are also alternate interior angles. Now I used all of these. I used 2, 4, 5, and 7, and those are all of the angles on the interior. So there are no more alternate interior angles because there are no more angles on the interior. Okay, new color. We'll move on to part C. Alternate exterior angles. Okay, exterior means I'm on the outside of the 2 lines. So I'm looking at 1, 3, 6, and 8. But they need to be alternate. They need to be on opposite sides of the transversal. So 6 and 3 are on opposite. 6 is on the top, 3 is on the bottom, and they're also still on the exterior. So angle 3 and angle 6 are alternate exterior angles, and angle 1 and angle 8. They're on the exterior and they're on opposite sides of the transversal. Okay. And we know that we're done because there are no more angles on the outside. We had 1, 3, 6, 8, and we used all of those. So, we can know we're ready to move on to the next one. Lastly, consecutive interior. Interior means I'm going to be inside, in between the two lines again, which means that I'm looking at these angles again, 2, 5, 4, and 7. But remember, I need to be consecutive. I need to be one right after the other. Consecutive interior, consecutive need to be on the same side of the transversal. They're not alternate interior. And they're not, they're not alternate interior, they're consecutive interior. So, you want them to be on the same side of the transversal. So, we'll talk about angle 2 and angle 5 are on the same side of the transversal, and they're both in between the two lines. And angle 4 and angle 7 are on the same side of the transversal, and they're in between the two lines. Okay, and those are all of the angles on the interior. 2, 5, 4, and 7. So there are no more consecutive interior angles. But we can check and make sure that we were correct. 1 and 5, 2 and 6, 3 and 7, 4 and 8, yup. Top left, top right, etc. 2 and 7, 4 and 5, yep. Alternate interior. 1 and 8, 3 and 6, yup. And 2 and 5, 4 and 7, Yay, we were right. Okay, if there are any questions, you know, I'm waiting for you in that Google Meet call. If you're watching this in 2020, I'm waiting for you in the Google Meet call to come ask me questions. You can email me, you can come to office hours, all those great things, but please get your questions answered if you have them. These are some practice problems that you can do to practice the skills you learned in this video. Remember that these are not necessarily your homework problems. You need to check in with your teacher about what your homework is. So don't just do these problems, do the homework that your teacher has assigned. But you can see they go with example 1, example 2, example 3. They go with their respective examples. Okay. And of course, our launch for today. Our launch comes from Helen Keller, and she says, keep your face to the sunshine, and you cannot see a shadow. Right? Because the shadow is formed by the sun rays hitting you, but not hitting the ground behind you because you're in the way. But if you're facing the sun, your shadow will be behind you because the sun is in front of you. So, while this is factually correct physically, it is also correct emotionally and mentally. If you focus on the positive things, keep your face towards the sunshine, look at the light, look at the positive things, you won't be able to see the darkness. You won't be able to see the shadow. So focus on the sunshine. Don't focus on the shadows. Because the more you look at the shadow, the more you're going to be stressed out about the shadow. And the more you're going to be freaked out by the shadow. But if you look at the sun, the more you're going to be like, wow. The more you're going to enjoy the sun. The more you're going to enjoy the positive things in life. So focus on the positive and enjoy the positive. Don't focus on the negative. Don't worry about the negative. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.